Welcome back. Right. Please, first off, know that this shape is not drawn to scale, but we are asked to find the missing length. And we are given this part to be 5 meter, from this point to this point to be 6 meter, and this point to this point to be 4 meter, right? So we're asked to find from this point to this point. Now, how do we go about it? Come closer. Let us do this together. Now, the first thing we need to do, we need to partition this shape this way, okay, such that from this point to this point is 6 meter. Also, this point to this point will be 6 meter, right? Now, from this point to this point is 4 meter, meaning from this point to this point will also be 4 meter. Now, what are we looking for? We're going to be looking from this point to this point. Let's call it X. Now, this gives us a right angle triangle. And now, what happens when you are looking for a missing part of a triangle, especially when you are given two sides and the third side is missing? We're going to be using the Pythagoras theorem, which says the hypotenuse side is equals to the opposite side plus the adjacent side. Okay, here the hypotenuse side is given as 5, and then equals to the opposite side, we can say is given as 4 plus the x squared. Is that okay? Now we can collect like terms. 5 squared is 25, equals to 16, 4 squared, then plus x squared. Now if this goes, it becomes 25 minus 16 equals to x squared. 25 minus 16 will give you 9 equals to x squared. Now recall, this can also be written as x squared equals to 9. And now to remove this squared from here, we'll take the square root of both sides, okay? So this will cancel, and then our x will be equal to 3. Now, if x here is 3, what is now the full length? The full length is now going to be x plus this part to this part, which is 6. And x is 3, so we have 3 plus 6. So meaning from this point to this point is going to be 9 meter. Is that okay? Bye-bye.